Welcome back to our channel, A.R.T's Real Repairs for Real Customers, meaning you get a chance to see what A.R.T's customers expect in a quality repair. The focus of this video is going to be incorporating plastic powder into our heat cure repairs. I think this will be of some interest to a select few repair technicians, perhaps not all, but I hope you find it interesting and intriguing anyway. Let's get into it. Why plastic powder, you might ask? Well, plastic powder has been around in our industry for a long time. And the way we've been using it, I haven't really got along good with it. Maybe it's just me. But yet the plastic powder has some great qualities. When it's embedded in a seat, you can't get it out. And you can't dissolve it out with acetone even. It's impervious to that. So you would have to get a razor blade or scissors and actually cut it out of the seat. And it's flexible too. So those are qualities that we could admire with our plastic powder. But how can we take advantage of these properties would be a good question, because the plastic powder is not necessarily going to stay where we want it. For example, on a vertical surface, it's going to fall out due to gravity. So we need something to transport the powder to the repair and get it to stay in place. Enter our heat repair compounds. Can we mix the powder with the heat repair compounds? That way, the heat repair compound will be the carrier for the powder, and we can think about basically repairing with the plastic, but now the repair compound takes a secondary step of just transport. Now, we shouldn't be afraid to modify any of our heat repair compounds. These compounds are made of plastisols, and they're used in various industries. Probably the most popular industry using plastisols is screen printing. You might also have used those little plastic worms for fishing, those little squigglies. Those are made from plastisol, which means you could make those worms out of your heat-cured vinyl repair compounds as well. So these plastisols already contain thermoplastics, right? These are plastics that will melt, and then when cooled down, they'll be solid again and can be reshaped and reformed. That's why these repair compounds work so well for us. But these other industries modify the plastisols to fit their goal, their target for the end use of the product. And so can we. We don't need to be afraid to up the proportion of thermoplastics within our plastisol. So if we add the plastic powder, which is a thermoplastic, to our plastisol, increase that proportion in there, can we make a product then that more closely resembles our repair target, our plastic or our vinyl that is the subject of our repairing? Can our repair product now more closely resemble our target? So I don't think we have to be afraid to increase that proportion. I think it's something we should have been doing all along. Let's take a look how that works out in practice though. If you wanted to test for yourself, take your favorite repair compound. In this case, you can see the one that's my go-to compound is rather thick, rather stout. It's very good for structural repairs. And I'm taking about an equal volume of fine plastic powder and just mixing with this repair compound. I want to take enough time to get it thoroughly mixed and distributed, but that proportion seems to work well for this particular compound. If I went too heavy on the plastic powder, my compound would be too dry, and then initially it wouldn't stick down to the substrate as I'm trying to put it in place. As always, use your good judgment. Here I've tried to duplicate the same repair, one with the compound normally and one with the plastic powder. So the white plastic powder leaves a more opaque look. Now I've cut rectangles into this vinyl and supported it on the back. That way we have equal thickness and two applications to see which hid these edges better after only two applications. Asking several people for their independent opinions, they said it looked like more grain was on the plastic side. I don't know if that's true, but we'll find out. The other observation was that the initial repair compound appeared more rubbery, whereas the plastic appeared more firm. So what I wanted to do is now add some color and make my own judgment and see. This may show off the texture a little better and show off these edges. It could very well be that there is a slight bit more texture on the plastic side. Definitely no lack of texture. Also, we have a bit more of an outline on the left, whereas on the plastic side it hid the outline a little bit more. Now, we didn't take great pains to do this, but I think there is some difference. I think we can see more filling on the plastic side. Now, as far as the feel, we have flexibility with the plastic additive, the same as we have with just the regular repair compound. This plastic part feels more like the vinyl, though. And if you look at this other side, it's more rubbery. It's more like that plastic worm. Now that the color has shown us the properties a little bit better, let's take the color off and see how it reacts to acetone. Normally, acetone is going to totally destroy a repair. It's not in this case because we have prepped properly and we've applied enough heat to fully cure our compound in both cases. So the acetone is not really harming us that much. So now with the second application of acetone, I'm discovering that there's more drag, more resistance on the side without the plastic. The side containing the plastic is still smooth. There is much more resistance on the left side. Not saying whether that's good or bad, that's just our observation thus far. So let's look at some examples in the field. This was my very first attempt in a high wear area with no support other than the plastic powder. Obviously, we have the flexibility, we have the durability. And I was excited to find that after 6 months of everyday use, it looked as good as the day I fixed it. The idea behind this test is to color my compound black, which I do sometimes for special occasions, and then we can see the distribution of the plastic once the compound is cured. This is over urethane. And we see the distribution of the white plastic powder throughout the compound. This shows how it's providing support throughout the entire repair. And here we're showing it off with a little bit of color so we can see better. We can see the texture is very good. Here's another repair over urethane. By the way, we're showing several examples, but we're not showing the full repair all along, just highlighting and keeping our focus on the role of the plastic powder. giving support here throughout the entire repair. Because the plastic powder adds so much more support in our base repair, I like to use it with the ironing method where possible, as we discussed in our previous video. It irons beautifully, and using the iron, of course, as we talked about last time, and this heavier Teflon, we do get a more uniform repair in our base repair. And here is our second application with the plastic powder. Pay extra attention to leave the chill bar on for a little bit longer than you normally would, because otherwise that plastic will still be gummy. You need to chill down that plastic even just a little bit more than you would chill down the vinyl repair compound as a rule. And as usual, a little guide coat color helps to see our progress. Here's where I want to put a specific texture. And so instead of using the texture of the Teflon, I'm going to use a graining pad and the heat gun. So we have a 1-2 punch of the ironing method and the heat gun method to finish out our texture. Let's get a little wipe-in color started. And I'm going to use my wood burner to clean up a couple of stitching. If you remember from the class in Las Vegas where we had to retrain those that went through a prior class, we did this repair using the iron and that Teflon and the plastic powder into our repair compound. This was the very first repair for the 3 students. In their prior class, everybody got a certificate, but they couldn't do the first job, which means all the students passed, but the teacher failed. This panel always gets dinged up in these Cirrus airplanes. When you pull out items from the back seating area, they a lot of times damage this panel. So I was interested in the plastic in the repair holding up better when it gets abused. This is the area that's hard to get to. My knees hurt me for 2 weeks after doing this repair. And this wasn't one of my best repairs either, but I had to leave it at this point. Another application for the plastic powder within your repair compound are these heavier plastic armrests, where you need some real structure. And there are plenty of these to go around, so you can understand the application there, how effective that is. Here we have serious damage on a flexing part of the seat. There was a hole in the leather. As you can see, we used the baseball stitch to hold it together, and then we ironed over the baseball stitch with the plastic embedded in the repair material. And this involved repairing over the stitching area as well. So it's imperative here that we have a strong repair as well as a very flexible one. So this is exactly what you've been asking for. I am going to show how I replace the stitching with what I call a faux stitch, where we emboss something that looks like the stitch line in there so that you don't see it from a distance. There are parts in the car that use faux stitching, only this is in reverse. But to the casual observer, it's okay. And you can tell it here because your face is up into the repair, but no one else would notice, likely. So we're building our confidence that the plastic within the repair material only helps. It doesn't detract at all from the flexibility or the appearance of the repair one little bit. I thought I'd throw this picture in. Here's a faux stitch on the center console where I fixed a big hole. The customer would have to look really close to see it. This repair is in a Nissan Xterra. You can see that the plastic powder provides a 3D structural support matrix within the repair compound. It bridges across all these broken edges without the need of any kind of backing or a mesh top support. And we've restored the feel of actual vinyl instead of this flippity-floppity kind of damage. And if that's not a real word, it should be. By the way, this is the knob that we took off that shaft so we'd have room to work. And as it appears on the shaft, notice that there's a grab handle on the spring clip that you can get a tool onto to pull that off. It's just too cool that it has a handle to make that job so easy. And of course, to reassemble, put the spring clip on that knob first and then just shove it on the shaft and you're done. What's not to like? Here's an example of another high wear area. You might want a little extra durability. This is some Mustang vinyl, which turns to plastic anyway, so why not a little plastic powder added to our repair compound? And I hope all these examples have inspired some ideas for you in your application. Thanks for watching.